So in today's lecture, we are going to learn the force, resultant force, force system, moment of a force, and equilibrium of an object or body. These topics we are going to learn in our today's lecture. In last lecture also, we have covered some of the basic concepts. And now, in this today's lecture, we will move forward. Okay. So, previously, we have seen the collinear force. We will just revise what we have seen yesterday. We have seen the collinear force system. This was the first one. Now, what is this collinear? Collinear means along same direction, in a same line. Okay. So these are the collinear forces which are along the same line. Second one, we have just seen the coplanar forces. Coplanar means in the same plane. Okay. Now these two forces are in the same plane, so therefore they can be called it as a coplanar forces. These two forces are coplanar. Third one that we have seen is the concurrent force system. Concurrent force system. Now, concurrent means what? Concurrent means all forces will combine at the same point, or they will emerge from the same point. So now these forces are emerging from the same point. So that's why you can call it as a concurrent. Okay. Or they will meet at the same point. So therefore also you can call them as concurrent. Emerging from the same point or intersecting, connecting at the same point. Okay. Now after that, coplanar concurrent. Coplanar concurrent force system. Now what is the coplanar concurrent? The forces will be in the same plane. Forces will be in the same plane, as well as they will meet at the same point. Okay. Forces will be in the same plane and they will meet or they will emerge from the same point. So this will be now coplanar concurrent. Means all forces are in the same plane. Here it may be in the same plane or may not be in the same plane. At the third one, that is the concurrent force system. In three-dimensional also these forces can exist. But here in the fourth one, coplanar concurrent means in the same plane as well as meeting at the same point. Okay. Now after that, next one. Fifth one is the coplanar non-concurrent. Coplanar non-concurrent force system. So what is this now? Coplanar non-concurrent. The forces will lie in the same plane, but forces will lie in the same plane, but they are not concurrent. So this is the condition here. Now I will draw one diagram so that you will understand. The forces are in the same plane here, but they are not meeting at the same point, or they are not emerging from the same point. So this is now coplanar non-concurrent. Then sixth one is non-coplanar concurrent. Now what is meant by this non-coplanar concurrent? Forces will be meeting at the same point, or forces will be emerging from the same point, but they are not in the same plane. So this is the non-coplanar concurrent force system. In our previous lecture also, we have tried to explain this, right? So again, we'll try to draw the diagram. So here, the forces are meeting at the same point, and they are concurrent in 3 dimensions, but they are not in same plane. Here you can see that these forces are meeting at the same point, but they are not in the same plane. So therefore, this force system is non-coplanar concurrent force system. Now, last one, seventh one, is the non-coplanar non-concurrent. Non-coplanar non-concurrent force system. So in this force system, what will happen that these forces will be lying into the different planes. So I will explain it on the same diagram. So the seventh one is the non-coplanar concurrent. Sixth one and seventh one is the non-coplanar non-concurrent. So in this diagram, we got most of the points explained diagrammatically. So I hope that you got cleared all these points. Now after that, we will try to cover one more concept here about the moment that you might have studied in your previous standards. Moment of force. Now, what is the moment of force? The definition for moment of force is it is nothing but the product of force and distance. Product of force and distance between the line of action of force and the point about which moment is to be calculated. Okay, so diagrammatically, we'll try to explain it. What is the moment of force? Now, suppose that this is the distance this is the force going downward. Let us assume that this force is capital F, which is going downward, and you want to calculate the moment of this force about the point A, which is located at this distance D. Now, the moment will be moment of force capital M will be equal to the force F multiplied by the distance t. Now, how is this distance? This distance is perpendicular. So remember this thing, that this distance is perpendicular. So if this distance is perpendicular, then only your moment will be calculated correctly. Otherwise, not. So moment here is equal to force multiplied by the distance at which you want to calculate the moment. So your this moment will be what? This moment is calculated at point A. Moment of force F calculated at point A. So remember this thing. Okay. And the condition is that the distance must be perpendicular between the line of action of force and the point at which you want to calculate the moment. That distance must be perpendicular. Then only you will get the exact moment of that particular force about that particular point. Okay. So this is the important concept of this moment. Now, after that, one more important concept is the resultant of a force. Resultant of a force. Now, what is the resultant of force? Suppose that there are three forces acting in the same directions on the body. Now, we are just giving an example here. Remember this thing. So, suppose that this one is the object. This is the object at which the force is applied. Now, suppose that this is having the magnitude of 10 Newton, first force. Second force having magnitude of 20 Newton. And third force having magnitude of 30 Newton. So these are the three forces now acting on this object. Now, if we replace these three forces by a single force, then that force will be called as a resultant force. You can replace these three forces by a single force, and that force must give the same effect as that of these three individual forces combined together. If these forces are acting in the same direction, then the addition will be takes place here. So 10 plus 20 plus 30, that is the 60 Newton. So the value of your resultant, capital R, will be equal to 60 Newton. Okay. So this is nothing but the resultant of a force. So I hope that you got this point, that what is this resultant of a force. So this one is the your resultant of these three individual forces acting on the same object. So what is the definition of resultant then? Your definition of resultant also matters, right? So there are 2-3 definitions of a resultant. So all of the definitions are having the equal same meaning. First one is the when a system of forces is acting on an object the difference between the forces is called as the resultant force. This is the first definition. This one is the first definition. Now, why the difference has been told? Because if, let's take an example, let's take a numerical here, simple numerical. If F1 is equal to 80 Newton, F2 is equal to 100 Newton, F3 is equal to minus 30 Newton. Find resultant. Now this is a simple numerical given here, that if your first force is 80 Newton, second force is 100 Newton, and third force is minus 30 Newton, all the forces are coplanar. All the forces are coplanar. Coplanar and collinear. Coplanar and collinear. Then find the resultant. If such numerical is there, then how you will find the resultant? By using the first definition of resultant, what it states, when a system of forces is acting on an object, the difference between the forces is called as the resultant. Now these three forces are acting on the object and the difference is the resultant. Now you need to plot these forces as per the given numerical. So your first force is 80 Newton, right? Second force is the 100 Newton, and third force is minus 30 Newton. Now, if this is minus 30 Newton, then it must be in a reverse direction. So you must note down this thing, that your sign convention matters too, and sign convention we are also going to discuss. Okay, so your first force is 80 Newton, second force is 100 Newton, and third force is the minus 30 Newton. So we are going in a very simple language. Very simple language. So 100 plus 80, that is the 180 minus 30 will be equal to 150. So the answer is very simple, that resultant R equal to 80 plus 100 minus 30 equal to 150 Newton. So very simple. But this answer we have calculated by using the definition of resultant. That is, when a system of forces is acting on an object, the difference between the forces is called as the resultant. So if these forces are coplanar and collinear, you can easily find out the difference by using the addition subtraction method. Okay, so this is the one simple technique to find the resultant of coplanar collinear forces. Okay, understood this thing? Now what if these forces are not in the same line, not in the same direction, not in the same plane? So at that time, we need to do the resolution for that force system or the number of forces. Okay, and that resolution we can have with the help of sine and cos. Okay, so see, we can also have resolution of forces as one of the important topic of the engineering mechanics, that is the resolution of forces. Now, how the resolution takes place? Suppose that this is your force and that force is having certain angle with the horizontal and this one is the vertical. Suppose that this is your x-axis, this is your y-axis. Okay. And you are having certain angle. Suppose that this angle is 30 degree. Suppose that this angle is 30 degree. Now, by considering the magnitude of this force, the magnitude is, let us assume that it is 50 Newton. You can resolve this force with respect to x-axis and with respect to y-axis. Okay, so how you can resolve this force? Suppose that this force is, we take the notation as F. F is equal to 50 Newton. Then how we can resolve this force as Fx equal to, that is the force, component of force 50 Newton along the x direction is equal to 50 cos of 50 into cos of theta, and theta is your 30 degree. So 50 cos 30 will be the component of force in x direction and component of force in y direction will be 50 sine of 30 degree. Now you all know the sine, cos and tan, right? So you can calculate by using your calculator, by using your calc, you can calculate these values. Okay, so this is called as the resolution of forces or resolution of force. If the n number of forces are there, then you can resolve that forces, and the resultant of that forces can also be find out by using the resolution. So you can find the resultant by the resolution. So next topic is finding out the resultant by resolution. Resultant by resolution. How you can find the resultant by resolution? Suppose that these two forces are there. Having magnitude 30 Newton and we have just assumed it. The magnitude is 30 Newton and 60 Newton. Okay. Now the angle of inclination is given for these two forces. The angle of inclination is given. This angle of inclination is 30 degree and this angle of inclination is 50 degree. If these two forces are acting on the same object, if some object is here, you can also draw the object here. If certain object is here, these two forces are acting on this object. Okay. And if you want to find the resultant of these two forces, then how you can find it? You can only find it by using the resolution. Now, how you can resolve this? This one is the F1. This one is the F1. And this one is the F2. So, therefore, the component of F1 along x direction plus component of F2 along x direction will give you the component of resultant towards the x direction. So this is the principle of resolution of forces. Okay, have you understood it? On left hand side, we have resolved only one force. On right hand side, we are resolving the two forces and combining these two forces. So what is the next definition of resultant? Is when number of forces acting on a rigid body, then these forces can be replaced by a single force which has the same effect on that same rigid body. Now this green color body is a rigid body and two forces are acting on this rigid body. Okay. And you have to calculate the resultant of these two forces. Now our time limit has ended here, and I have taken the attendance, and this lecture will end.